My name is Dawid Kublik, and I'm still working for Finance IT. And I am a senior developer and team leader there. And some time ago, we moved with our project from Maven to Gradle. And I know that many people hate Gradle, but I've been a big fan since. And I already had some presentations on Gradle, and I'm talking both about some Gradle tutorials and presenting Gradle internals. And it was kind of difficult for me to choose the topic for today, only half an hour time. But I decided that I will show you some really Gradle basics, but not the tutorial basics. I don't want to do that. There are plenty of tutorials on the web, and I know that probably most of you know Gradle and use that. But I will try to show how exactly it is working under the hood. So what method is called, and what are the delegates, and things like that. And yeah, so this is actually my plan. So at the beginning, I will just tell you a little about Gradle. So once again, I know that you probably know a lot about it, but still it's only build tool. So people don't like to learn about it, don't like to read about it. And it's easy to miss some philosophy. So I will just tell you about some philosophy of the Gradle, and then I will move to some examples. And the first question that comes into your mind probably is why to learn about internals? Because Gradle, there is like, Gradle team put a lot of work, put a lot of effort to make this Gradle DSL, and DSL is about hiding the internals. And now I'm going to tell you about it, about the internals. But I think that actually investigating it and checking it, it's fun. And actually it helps you to put some perspective on the whole building process, because when you know how it is working from this low-level perspective, then it is easy to spot some mistakes, and I will show mistakes that are easy to make. And for example, in Gradle also we have many things to do some stuff, but many possible ways. But so some people could not understand why there are two ways of doing that, but not one. So it also became obvious. And another thing is that recently, in my impression, there are a lot of technologies that developers treat a little like magic. For example, Spring Boot is one of them, and Spock is one. It's just working, but how, nobody seems to know. And then there is Gradle. It is working. This is some DSL. And I will try to demystify that, because it is not magic at all. It's just working because of the Groovy, and I'll try to show that. So I will use very simple examples, like some basic tasks to present all of this. And I think that this is actually the great way to learn how to write this real purpose, real life DSL. So I'll try to show that. Gradle is of course the build tool, and in order to have some build, we have to have some life cycle. And here there are two examples of the life cycle. The upper one is the Maven life cycle, and the bottom is from Gradle. And those two look very similar, but actually they are completely different. So Maven and Gradle have this totally different approach to show how the build is being made. So in Maven, we have linear faces, and to those faces, we have ghosts attached, and there is strict order. So Maven, it assumes that it knows the best way to do things. I mean, if you want to change something, if you want to change the behavior, it is difficult. It is, and Gradle is much more flexible in this area, because in Gradle, everything is built on the top of tasks. So actually there is no strict life cycle that is defined. There are only tasks, and then those tasks can depend on each other. And from that dependency between the tasks, the life cycle is created. And this is what differs in those two solutions. And of course, Maven was a big step forward. I mean, because before Maven, we had just Ant. And when I'm talking about big step, I'm not talking only about Maven repository. I'm not talking only about managing dependencies, but also Maven introduced this convention, and Maven introduced standardization. And before that, when we had Ant, and actually I do remember that, so it was with every project, you were some kind of reinventing the wheel, like we are starting from the scratch, starting from the beginning. So for example, when you joined the project, you didn't know what to expect because, okay, there was no standard way to pull your sources even. There was no standard way, so you don't know where to expect the libraries. And you don't know what task are you gonna see there. And nothing was standardized. And then the Maven showed up. And it standardized everything. And it was cool because there were those regular places, there were those regular tasks. And so now when you joined the project, you were familiar with everything from the beginning. But few people felt that actually Maven took this point to the extreme. So now when you tried to customize something, it was difficult. Like the only way, for example, was to write a plugin. And even some simple tasks as copying files from one point to another are done by the Ant plugin. So this is what the Maven is not so good at it. Because like Maven was extreme, because before we had this imperative way of working. So with Ant we were just giving orders. So we are telling you by the scripts, okay, I want to take these files and put them here. I want to compile them and do that. So I was giving an order. That I want to do this and I want to do this in this way. But with Maven, like, it knows everything. So it knows the best way to do the things, but it is only asking about the outcome. So, okay, the outcome should be like this, and I know how to perform the whole task. So, like, it missed this imperative way. And then the Gradle came out, and I put the Gradle like somewhere between the Maven and Ant, but actually this is not correct because Gradle actually spans. It takes all because there is this imperative approach and there is this declarative approach. So Gradle is designed like more to be language, not a framework. So like the idea here is like let's make a language to tell some stories, and those are build stories. Let's use Groovy like as a glue to tell your individual story. So you can do anything because it is language, it is flexible. But of course there are some standard stories that were told like many times in the past, for example, how to build Java project. So let's not like tell it from the beginning, let's not reinvent the wheel once again. So in this way we can use some plugin that knows how to do the work. But it's up to you if you want to use the plugin, or it's up to you if you want to write the task from the beginning. And you don't even need to write the task from the beginning. You can use some existing task to do that. So this is what is great in Gradle. And as I mentioned before, it looks bad here. Okay, but it's only one slide. So yeah, okay, so this is some example of the task. And as I mentioned before, like in Gradle, we do everything with the tasks. And like tasks can do like many things. For example, in the Gradle plugin, tasks can compile some sources, tasks can test some classes, tasks can make some jars, but they can do many other things, like for example, packaging, for example, copying, and even simple thing as just printing the message. So what we are doing here is actually creating task with some name, and we are defining some actions that this task should perform. So like tasks, normally they perform like one or more actions, and those actions are just collections on things to do. So what I'm saying here is like create some task, then define the action, and the action would be to print some message, and I'm telling to the Gradle script that I want to put this action at the end of my actions collection. Then I'm defining another action, and once again putting it at the end with the doLast method. Then I am defining another action, and this time I'm putting it at the first, so at the beginning. So then when the task is executed, all those actions will be executed in this order. And it's that simple. And this is how we can define like many tasks we can build on the existings and define like everything. But one important thing to notice here is that actually in this script, and we are not calling and not executing anything. Like Gradle scripts are configuration scripts. So in Gradle script, you won't find like, for example, call to other tasks to execute it. It's very different from the Ant perspective, because in Ant you were using scripts, and in those scripts you were telling, okay, let's do that, and copy those files from this directory to the other, let's build those files. But here, no, this is like the declarative part. You are just configuring. So you are telling like, okay, this is my task, let's configure it. It will be called and run sometime later. And this later is like another phase, because in Gradle, and this is also like very easy to not know about this, we have like different build phases. And the first one is configuration phase. And this is the phase in which the script is actually run. So like the whole script is run only in this phase, and the outcome of this phase is the task model, like task graph, that contains all the tasks and all dependencies between them. And then when everything is built, when the whole script is read, then there is another phase. And this time, this is execution phase. So based on the model that we built in the previous phase, we are just executing one or more tasks. OK, and now I'm going to show you some build script. And it's here. So this is the part that we are moving to examples, and those will be like very basic examples. And I have some few tasks defined here. So this is like the basic Gradle script. So yeah, so this is Groovy. So in Groovy you can do everything. Yeah, in Groovy you can like define some methods, you can create some objects, you can call some methods, like here, print some messages. But Gradle script is something more. Gradle script is configuration script. So what do we mean by configuration? It's supposed to configure some object. And the object that we are configuring, it's called delegate. And the delegate of this Gradle script is the project object. So like when we are calling the script from the top to the bottom, we are actually, in most cases, just calling methods on this delegate. And we can even check this in the IDE. So if I check the task, we can see that this is just some method on the project model. And project is just the part of the Gradle. And this will be executed. It's taking one argument. And this argument is the task name. So here I'm calling the method with this argument. And actually, this is not completely true, because IDE is actually lying to me here. Because as I showed you, that it is this method that is being called. But it's an easy mistake. I know that you are all Groovy experts here, but for a person that is not used to Groovy, this actually might look like the definition of method. But actually, it's not a definition, it's a method call. So what we are calling here is a method called task, but not with one argument. We are calling this task with two arguments. One is the task name, and the second is closure. It's here, yeah? And the second is closure. And this is like the configuration closure for the tasks. Because in Groovy, as you probably know, it is possible to skip the braces. So there are actually two arguments here. And so if we look at the task delegate, it's actually not this method that is called, but this is this one. The first is the name of the task. The second is the configuration closure. And actually, you may believe me or not, but I'm gonna show you show it to you in the running example. So what I'm gonna do is run this task and try to debug Gradle and show you exactly what methods are called. And so it might seem difficult because, for example, if you imagine how to debug Maven, that probably is difficult. I never tried to do that. But with Gradle, it's totally easy, because I have a project set up here. And a few versions ago, Gradle introduced something called Gradle Test Kit. So this project is very simple. Actually, if I need to set up it, I only need to provide this configuration script. So I'm just applying the Groovy because I want to use some Spock tests repository, and then there is only this dependency that is important. And now it is possible like to run embedded Gradle, and it is possible to debug it. So I'm going to debug it with this investigating specs. And this is very simple Spock specification. And what I'm doing here is I'm taking this task that I wanted to investigate, and I'm going to run it. So what I'm doing is creating some temporary folder. In this temporary folder, I'm adding build Gradle file. I'm populating this build Gradle with this task, and I'm gonna check which method actually is run. And I'm gonna to run it with the object called Gradle runner. It's only taking a few arguments. I mean, this builder can be customized with few arguments. So one is this temporary directory I created. The second is the name of the task that I want to run. And actually, if I run Gradle from this specs, it would be run in the separate process. So it would be impossible to debug it. But actually, there is one more convenient method. So if I run with debug true, then it will be run in the send process, so it will be possible to debug it. Yeah, so I'm running it now. Yeah, and this is actually just the thing that I told you before. This is the method that is called, and one is the task name, and we can check it here. And yeah, probably improper, that was the name of the task, if you remember. Yeah. And the second is just configuration closure. One second. Yeah, I missed it somewhere.
Configuration closure.
Yeah, I want it to be here. OK, so the configuration closure. So what is actually going on here? So like the first thing, the task is being created, and it is created here. So it is just, yeah, we can check it inside. So it is created and then added to some task repository. But the other thing is that it is configured here. So like configuration is just taking another closure, and this time this is this closure, and this closure is run immediately like here on the task. So actually what I'm doing here is just creating task and immediately run some configuration on it. That's basically it. So now, having this knowledge, I'm going to show you like one more example. So, having this knowledge, now I'm trying to explain why there is that much difference between those two tasks. I mean, this is like the mistake that is easily made by people who just start with Gradle. I mean, those two looks almost the same, and the only things here is this shift operator. And this changes everything, because this message will be printed in configuration phase, and this message will be printed in execution phase. But and I can show you that. So like this is, as I mentioned before, just the Groovy script. So it will be like executed from the top to the bottom. So I added some print messages like to show where are we. So here will be close to the start of the configuration phase. In the same manner, at the end will be like at the end of reading the script, because everything is evaluated from top to the bottom. And I also added like one listener, and it will inform me when configuration phase is finished and execution phase has begun. So by this, I could check in which phase those tasks are executed. And I'm going to execute it. So those are all the tasks from my script, and probably improper. Let's check this one. Okay. Yeah, it won't run. Yeah, I just check just one thing because it's Windows and sometimes those. Yeah, so let me just check one simple thing. Yeah, this is it. Yeah, I mean, don't ask me, okay? So yeah, I've heard that comment. Yeah, so. Yeah, okay, and it runs. Yeah, okay, so we can like investigate the output. So, okay, so here we can see that this is where the configuration phase is. And this message from this task, probably improper, like the name here is no coincidence, is printed in the configuration phase. Then we can see that here we are in the execution phase. And okay, we can see that the task here was executed, but no message was printed. Yeah, I mean, and it's simply obvious because as I showed you before, like the configuration closure is executed immediately after task creation. So that's why it was executed in the configuration phase. But now, if I run the second example, this one, then we can see that this time the message was printed in the execution phase. But we can notice here something more. We can notice here that also the message from the previous task was also printed, but this time we called the different tasks. And it is like common mistake. And of course, this is again obvious because, okay, we were not running the previous task, but we were configuring all the tasks in the script. So like the previous tasks was not run, but still configured. So if you like write the task in this way, it will be like executed in the wrong phase. Okay, but how is it possible that this closure is not executed immediately? I mean, to understand that, you have to understand that this thing, this left shift operator, is just the shortcut. And like the full version is this. This is just the easy way not to write everything this do last. So here, when we are executing the task, we are actually, again, calling task method on the project with two arguments. One is the name, the second is execution closure, and then this closure is executed on the task. But this time, executing this closure means let's execute this method on the task object. So we are on the abstract task, and calling this method with this closure does not mean to execute this closure immediately. We are just adding this closure to the actions, and actions will be executed in the later execution phase. So somewhere in the future, and actually this future place is somewhere like execute actions task executor. So actually this is what will be run in execution phase. I wanted to show you because this is exactly what I told you with the task slide. So here we are simply executing this task, and executing the tasks means just taking all the actions from the tasks and running every action. And it's simple as that. So now knowing all of this, we can we can rewrite this task creation in a less DSL but more obvious way. So I can show it here. I just uncomment it. So, and this would actually work, and this one is self-explaining because, okay, here, this stuff is just exactly the same as this. So I'm working the task method on a project with two arguments. One is the name, the second is the configuration closure. And with this, yeah, it's the same. We are calling this method with this configuration closure. Then this closure will be run on the task. And with the shortcut, it's almost the same, because here we are creating like the task with just one argument, and then on the task we are calling left shift. But this left shift, it is doing exactly the same as do last. So it is adding the action at the end of the all actions collections. Yeah, so this is it. Okay, and I will try to show you one more example. So, okay, here we have like another task definition, and this time we are defining some task with the type of the copy. And this is again some task that Gradle is providing with the framework part. So it is copying like the file from one file to this directory. And here we are doing two things. So once again, here we are calling just the task method, this time with 3 arguments. One of them is the task name, the second is configuration closure, but the third is the map. And this map is telling you that the property of type will be copy. And okay, so it is working in the same manner as the previous example, but here there is a little more magic in this place, because now here we are actually not creating the new task. We are just configuring the one that we created above. So for some reason, we are changing the into property from backup to backup 2. But I told you before that all those calls are actually calls on the project delegate. But of course, there is no backup build method on the project delegate. So how is it possible like to find this method? And I'm going to show you that as well. So we are going to investigate this example. We just take our investigation paths. We're going to add it like few more tasks here. I will keep the first task just to give some perspective. And what I'm going to do is add more debug point. So there is no this method on the project delegate, so I'm expecting that we are actually gonna end up in the method missing method, and I'm gonna to put my breakpoint here. Now I'm gonna to, of course, now I'm gonna run different task. Okay, so it's not the place we were expecting. This is also not the place. No, this is the place. So here we are really, so there was no, so of course there was no backup build method on the project delegate, so we ended up in the method missing, yeah, and we are looking for this method. And I told you before that the project was the delegate for our script, but that was actually not the whole truth, because the project was just one of the delegates, and there are a few others. So here we can see that the first delegate was the root project, but the last one is the collection of all the tasks that we added before to the script. So all the tasks will be searched, and the method will be called on one of them. So this is like the part where most people complain about Gradle, because this is why, because it is implemented on method missing. So it is like very difficult to make the IDE give you like some hints on on how to implement it. But it is done in this way because there are like several delegates, not just the one. And I can see that. Okay, so I will, there's a little time, so I will end up just with telling you this, that of course, there is no need like to investigate the project. You can still use those top-level script blocks that you can find in the Gradle DSL documentation. So yeah, you can just go there and find those like magic words, but knowing all of that, that I presented, like those magic words, now suddenly they're not magic anymore. Now you know that they are just the method calls on the project, which is interface, or abstract project, which is implementation calls. And so those are just the methods that are executed on the project, and those methods usually just being forwarded to some like specialized executor, for example, task container, project registry, repository handler. And we can actually see that. So, for example, in the project, when we are calling repositories, and you know this like from the Groovy script, we can see that this is actually just the forward to the another delegate, and this is repository handler. And by investigating repository handler, you can check. You don't need to check the DSL anymore. You can check that all the methods that you are gonna use are just here. For example, JCenter, Maven, Central, and things like that. So you don't even need to leave your IDE, like to know what are the options possible in your Gradle script. And I would like to finish with that. I also have some examples on the plugins, but my time is running, so I guess that would be it.